write the rational function. We have went through many sketching rational function from the previous videos. So now we progress through to write the rational function. This topic can be tricky if we did not learn how to analyze the characteristic of the rational function. For example, vertical asymptote, horizontal asymptote, oblique asymptote, x and y intercept, and how to find the point of discontinuity, which is the home on the rational function. So we have went through all of that lesson. So now we progress through the lesson of writing the rational function using the given data, given information, and we'll be able to write the correct rational function. So let's take a look at how we're going to do that. So on the board, I have the question written it down. So let me read it to you. Write a rational function g of x with a vertical asymptote at x equal positive negative 3, a horizontal asymptote at y equal -4, and no x-intercept. So this type of question I found is very challenging, right? Because we don't have the graphic, we don't know what is the shape of the function look like. We just given a bunch of data, and if we remember what we learned so far, then it's okay to do this question. If we forget, then we get into problem, right? So let me give you a hint how to do that. Before I get into this question, I just remember when I was teaching 5 years ago, I was teaching in the classroom, and I gave out the test for all my students, and the test about solving the quadratic equation using the completing perfect square. It took me a whole month to teach my student in the public school how to solve the quadratic equation using completing perfect square, because it's a little bit complex concept, right? And my student learn it for like this. The quadratic function unit is about the whole month. It took us the whole month, and then after all of the process, it takes times to learn. Finally, my student came up with the answer in just 1 or 2 seconds. I was shocked. He gave me the answer x equal, I don't remember, but let's example say x equal -3 and x equal 1, something like that. Then I asked him like, how could you be able to find the answer solution so quickly? That could you please show me the step, how you do it? And then he looked at me and he said, I didn't know. I key in the calculator. I got the data in your question to ask me. I keyed it in and I got the answer. So I asked him what kind of calculator. He said that is casino calculator, Raphing calculator. Now, I think the latest version I would like my student to use is this Raphing calculator, TI-81 or TI-84. Now, the casino one is, I have to say that that's the one, like, in my opinion, right, is the one who took over the math subject, because I taught this topic for a month, how to solve it by hand. And he just key in for 1 second and he got the answer. Then he asked me, are they correct? Of course they are correct. But when I asked him to show me step, he didn't know how to show it. Right? So, and that's why I remember and I related to this question today. So in this question today, we are safe. We can use the graphing calculator, but not in the way like my student used it before. He didn't have to know how to learn the completing perfect square. He came up with the answer right way, right? And that's not the way we want the calculator to took over the math topic, the math teaching. So let's get back to this question right now. And in this question, I would like to show you how we write the rational function, but also we will key in the function on our graphing calculator rather than sketching it by hand like other lesson. But without other lesson, we're not going to know how to write this equation because this is a complex question, right? So I'm glad that I be able to organize my lesson in the sequence of the logical sequence of math language. So anyway, we're going to write this equation. So first of all, we know the name of this equation is g of x equal, and we're going to write as a function, right? That's the rational function. So what we're going to put on the top and what is the denominator? Now, if we read at the first data, it says vertical asymptote at x equal plus and minus 3. It means we will have two brackets. One is x times with minus 3. Another one is x plus 3. They time together. And this is show us the vertical asymptote at x equal 3, because if we put 3 in here, 3 minus 3 is 0. And x equal minus 3. Minus 3 plus 3 is 0. It blow up the bottom, and 0 times with anything is just 0. So when the denominator is 0, that is where the function does not exist. And therefore, we have the vertical asymptote at this, and we'll be able to establish our denominator based on this given information. What is the next one? It says a horizontal asymptote at y equal minus 4. So what's going on for the rational function have a horizontal asymptote at y equal minus 4? To have a horizontal asymptote, we have to have a degree on the numerator of the numerator, and the degree of denominator have to be equal. So basically, if we have x squared divided by x squared, or x to the power 3 divided by x to the power 3, or 4x to the power 7 divided by 2x to the power 7. So their degree have to be the same. And the reason, because we already analyzed in previous lesson, we look at the y function, y value, where the x approaches to a large number. And so when x approaches to a large number, negative and positive infinity, then we want to ask what is y value. And that y value is the horizontal asymptote, right? Because the horizontal asymptote is go through the y value right here or down here like this. So therefore, if we have a degree the same, right? Let's say x squared divided by x squared. Then we can cancel them. And what left over is y equal minus 4. So this had to be minus 4. So now we know this had to be the numerator of this function. And the reason, because x, the denominator, x times x is x squared. So we have to make sure that our numerators also have a degree of x squared. And that's how we write it. So now, what next? Is say no x-intercept. If we write like this, and then we're happy with this, and we say, okay, so should be okay. However, if we set y equals 0 to solve for x-intercept, then at this point, the x will be equal 0 as well, and the y also equals 0. So actually, this is contradict with this condition. This is the x-intercept, even though it's 0, but it's a valid point, it's the x-intercept 0. So we cannot just leave the numerator like that. It means that we have to change it. We have to do something with it, right? So what is the idea to do something with it? Because we have to keep a -4 here for the horizontal asymptote happen. So this gone, right? And the horizontal asymptote happened at y equal -4. So we cannot change this number. Now, if I toss in any number, let's say I toss in the number 6, as long as this is z equals 0, and when I solve it, I move it over, so 6 becomes -6. Now I divide both sides by -4, then obviously I get into the problem that, wait a minute. So if I put a +6 here and move it over, it's -6. And that's right. And then I divide this. So this turned out to be a positive reduced to low fraction 2/3. And therefore, I'll be able to take square root of 2/3, which is, I ended up that, yes, I do have an x-intercept, which is square root of 2/3. And that is, again, contradict with this. So I think that if I check it and I say, wait a minute, what if I don't want an x-intercept? I'm going to change the sign, instead of positive become negative. And let's see how it look like. So I will solve for the x-intercept, right? I set y equals 0. So -4x squared minus 6 equals 0. Move it over, -4x squared equals positive 6. Divide both sides by -4. Then this gone. I left with x squared equal a negative number. And remember, on your calculator, if you take the square root of negative number, you got into the problem of the error. It means that we cannot take the square root of a negative number. So we know that therefore there are no x-intercept. So by changing the sign here from positive to negative, we'll be able to satisfy this condition. No x-intercept, because we cannot solve for it. It's the undefined. So basically, now we'll be able to establish this rational function based on the information they told us. And it seemed that we satisfy with our function. So the next step, I would like to show you the calculator, right? On the roughing calculator, we don't have to sketch it by hand anymore. The purpose, we want to sketch it by hand because we want to analyze what is the x and y intercept, what is the point of discontinuity, what is the home, what is vertical asymptote, something like that. But now we passed that. So let's use the roughing calculator and check it out for fast, right? So this is the time when I want my student to use the calculator, not like give me the answer without doing anything, right? That's not the way we should learn math. In my opinion, that's like a cheating, but I don't know. So let's see. I'm going to key in, right? So I'm going to show you my calculator. I press this button, and now I'm going to key in the equation. And we have to be careful when we key in the calculator because sometimes only missing a bracket, it will cause a problem and you not be able to get it correctly. And you might confuse and you might say, oh, maybe I did something wrong, but let's see. So I'm going to key in, and I have to use the minus down here, right? I cannot use this minus here. For the first number, minus 4x squared minus 6 divide, no, sorry. Sometimes I just feel I better use hand. 4x squared minus 6. Okay. Minus 4x squared minus 6. Close the bracket. Divide it. Open the bracket. And for the bottom, I suggest to you that we have to open 2 brackets, right? When we write, we don't have to, but on the calculator, we have to do that. Otherwise, we don't get the correct answer. So x minus 3 times with x plus 3. And we'll close 2 brackets. So that's how you key in your calculator. That's how it should look like. So make sure the number of opening bracket equal the number of closing bracket, right? So 1, we open 1, 2, 3. We close 1, 2, 3. Yeah, so that should be okay. Now I'm going to draft. And I believe that something wrong because probably the zoom is not correct. So I'm going to change the zoom to 6 standard and see how it looks like. So now it looks right. Right? So now let's check the feature on the graphing calculator. Does it, do they match the data given? So first, you can see that we have 2 vertical asymptotes, right? On the left and on the right-hand side at x equal minus 3 and positive 3. Now, on graphing calculator, it's hard to check vertical asymptote, but it's easy to check horizontal asymptote because the horizontal asymptote have the equation y equal. So I'm going to check that. I'm going to hit this one. And we'll key in y equal minus 4. So the second equation will be minus 4, y equal minus 4. And I'm going to draft again. Now you can see that it shows you the horizontal asymptote right there. And if you check the scale on the y-axis, 1, 2, 3, 4, you can see it across as the 4 value, right? Okay. So that's correct. Now, what else do we need to check? We have no x-intercept. So let's key in x equals 0 and see what happens. To do that, you have to hit trace on your calculator. You hit this button, trace. And now you enter x equals 0. And you enter. And no x-intercept. Now, actually, we do have the point here look like minus, it say minus y equal minus 0. No, sorry, positive 0.666. So, no x-intercept. How it happened? We know that we cannot take this value. So why do we still have an x-intercept here? What's going on here? Okay, let me try it again. So sometimes we run into the problem like this, right? So we have minus 4x squared equal minus 6 move over become positive 6. Divide both sides by minus 4. I do slowly so we don't get error. We cancel that. We have x squared equal, you see, plus divide by negative become negative 6 over 4, which is negative 2 over 3. And we never can take the square root of minus 2 over 3. We never can do that, right? So we shouldn't have an x-intercept. Yeah, we shouldn't have it. So let me see. Now, if I get rid of it, okay, let me key in square root, right? Now I'm going to put in minus 2 over 3, which is minus 0.666. And enter. You see it say error. So we shown by hand actually is more accurate. It's better, right? You can see that it's say error here. So obviously we cannot solve for an x if this side is negative. That's correct, right? So our analysis is correct. Now, let's check why it happened like on the graph. Maybe because we didn't interpret it right. So let me put in trace again. Now on the roughing calculator, x equals 0, y equals 0.66, and you can see that, right? But we have to know that there's a hole in here, right? We just didn't see the hole very well, but there is a hole in there and it's highlighted, right? It show it highlight, it's flashing. So maybe that's a signal from the roughing calculator showing that that is a hole. It means we do have a y value if x equals 0. The y we calculated out becomes 0.666. However, this is not the valid point. So probably the calculator is flashing that, highlight that is the hole. And on the calculator, you never can see it as a hole as we sketch by hand, right? But that's how it looked like. Okay, so let's accept this is the correct question based on what we know what we're doing, right? So let's move on and accept this question for now. Now you will see we're going to do the second question, right? So we will see more when we do the second question. So is there anything else we missed? That's it for this equation. That's how the graph look like. And that's how we try it. Now let's try the second equation. And probably I should set my calculator again, otherwise we'll say reset 1 and 2 for layer on the RAM. So now I clear on the RAM on the calculator. And sorry for this button. I think this one because it's the, I don't know, I put my calculator under the sun and it's damaged. But I don't have money to buy a new calculator. I'm a poor teacher. Okay, so let's see what we're going to do for the second question. So for the second question, we're going to write an equation given vertical asymptote at plus and minus 3, horizontal asymptote at y equal 2, and x intercept at plus and minus 5, a hole at x equal 4, and a point of discontinuity. A hole, you can say this is the point of discontinuity, the same thing, right? So let's establish this equation. Now, this equation doesn't have a name, so let's name something, maybe f of x. Doesn't matter, right? Now, let's establish the rational function. So what do we have for this equation? First, vertical asymptote at x equals plus and minus 3. So again, we will have two brackets look like this, timed together at the bottom. Horizontal asymptote at y equals 2. This is the degree 2, right? Because x times x is x2. So on the top, we have to have a same degree. And we want, when we cancel it, we have the y value at 2. So we just add a 2 on top, just like we did here, right? So we're going to have some kind of, just keep in mind this for now, right? We'll do something like that. But let's look at here. We have an x-intercept equal plus 5 and minus 5. So in this question, we do have an x-intercept. And when we set our numerator equal 0, we will be able to solve for an x-intercept. And therefore, we'll make our numerator two bracket x plus 5, because when we set it equal 0, we solve for it, we get x equal minus 5. Here, x minus 5, when we solve for it, we got x equal 5. So now our numerator should be like this, so that we can have an x-intercept. What else? We need the horizontal asymptote at 2. So again, this time that will give us the same degree like down here. So that's no problem. We're going to add the 2 in front. So that is how it looked like. What next? We also have a home at x equals 4. So when we have a home at x equals 4, it means we have to have a factor on the top, x minus 4, and the bottom the same. So we can cancel. Remember, the home mean we can cancel the top and the bottom, right? So now we know that our function is not long enough. So we have to add an x minus 4 on the top, time with the x minus 4 at the bottom. For the home to happen, right? So that we can have a home. Now, what else do we need to do? I think that's it for now for this function. So let's erase this one. If you key on the calculator on this to sketch the function, it will be a tedious task because we have so many brackets, right? We still can do it, doesn't hurt. However, to make it simple, we can simplify this function down and then key in the calculator, right? So now if we simplify this function, we can cancel this bracket and this bracket where it have a home, right? And our function now turn out to be, I can change this into a perfect square, right? Because this is the formula of perfect square, difference square, right? Difference square. So I will make like something like this. A plus b times a minus b equals a squared minus b squared. So our a squared is x squared. Our b is 25, b squared, right? Divided by, down here, we also can turn into the difference square as well. So we have x minus 3 times x plus 3, we can express as x squared minus 9. And when you key in the function in the graphing calculator, it's not going to show you this and this. But because this equation and this equation exactly the same function, so it's not going to change anything, except that depend on the question. When the question asks you to analyze it, it's not going to give you this form. It will give you something like this, right? Or maybe even though simplify further, so I can write this as 2x squared on top minus 50 over x squared minus 9. Once they give you this question, but they ask you to analyze it. Then you'll be able to factor it down, breaking it down like 3 brackets like this. And at that time, you will realize what is a whole here. However, because we just want to check whether do we write the correct equation, right? So this is supposed to be a correct equation. So let's and actually, when you write the equation, if they just give you this equation, right, then you can break it down like this. But you're not going to see the whole here unless you have to keep it the same like on the top. So if I just write this in this form, then I don't have the whole here. But in order to have a whole, to establish the equation, actually you should have all of this information, right? You should have all of this information. But when you remember, when we sketch by hand, right, we also cancel out this as well. But when we sketch the function, it doesn't affect, it's the same shape of the function, except that we know when we sketch by hand, we'll know how to put the function, have a hole like this, something like that, right? If we sketch by hand, we know, if we know the hole right there, we'll be able to mark the hole. It's hard to see it on the calculator, but that's the case, right? So if we have the equation like this, and we know that we have a hole at x equals 4, then we're gonna make a hole right there. But when we get the function, the hole doesn't affect the shape of the function. So let's key in the symbol shape like this, right? A symbol equation. Let's use a symbol equation and sketch the function. So let's say if we key in 2x squared minus 50 on top and divided by, open bracket, x squared minus 9, close bracket. Now let's sketch it. So this is how the function will look like. Once we write the equation and we'll be able to sketch, so what is that? That is the lucky side, right? So that's already tell us that, oh, maybe we did correctly. That's why we'll be able to sketch the graph. But let's analyze on the graph to see, are we correct? Are we contradict with the given data, or we okay? So let's check. Now we'll not be able to check the whole, right? But we're going to check the horizontal asymptote at y equal 2. So I'm going to key in y equal 2, enter, graph. Now you see that, yes, we do have a horizontal asymptote, go through it at 2, right? At y equal 2. Now we're going to check the x-intercept. So we'll say if x equals, and make sure you hit trace, right? We say x equals 5, what happened? And it's true. If x equals 5, y equals 0. So that x-intercept. Now, if x equals minus 5, what happened? We do have y equals 0 as well, right? On my calculator, you can see it, right? So it means that, yes, we be accurate. We be able to sketch x equals 5 and x equals minus 5, x-intercept. Okay. What else do we need to check? Now, vertical asymptote, you can see that, right? It doesn't show us, but you know that because there's a line here where the function never reach it and go to x minus 3 on the left side and x3 on the right hand side. You can see that from the graph, even though we cannot check the value, but we see it, right? So it seems everything okay at this point. So keep in mind, this is the rational equation in the first form, or you can cancel this and write like in this, the final form, given on the data like this, right? Remember, even though we cancel this one, right? It doesn't affect the symbol form of the rational function, except that if we don't have this one, then we're not going to draw the home. We're not going to sketch the home. But if we be able to factor out, and we got this and this, and we can cancel, we will know that where is the home as it. And we'll be able to find the y value of the home as well. So let's pretend that we have a home here. So let's see what happened, okay? So I'm going to key in x equal a home that's x equal 4. So I'm going to say trace, I'm going to say x equal 4, and I enter it. Now there's the highlight value here. So as that value, we know that we have a home at x equal 4. And the y value somewhere right there. But you have to know that the y value does not exist, right? Because that's the home. The home, it means at that point, the y function also does not exist. It's just a small home, right? But we'll be able to identify what is the y value of that home and what is the x value of that home. But on the equation, when we empty the circle, a home means the function does not exist at that point, at y equals something and x equals something, right? Wherever the home is. Okay, so I'm going to turn this up now. And let's do a last question, right? Because this topic is a little new to you. So let me select another question here for you to do it. So let's say if we have the question say the same, like I'm not going to repeat this, try a rational function for vertical asymptote at x equal 1/4. Let's do the function now. X equal x-intercept, we do have x-intercept equals 0. And point of discontinuity, point I put in the short form, right? Point of discontinuity is at x for 5, x equal 5, and y equal 5/90. Okay, so now, so remember this is a home, right? A home on the function. The y is the not exist, but we'll be able to identify the coordinate of this home here. It doesn't mean that the x and the y exist. It means that yes, at this point we have a home. Okay. Now, how are we going to write this one? Discontinuity and the x-intercept equals 0. Okay. What else? I think that's it. Okay, so let's see how we will write this one. So to establish this, I'm going to name this function as h of x equal. Now we have vertical and x equal 1/4. It means that we have something like this. 4x 4x minus 1 as a bracket at the bottom, as a denominator. Why? Because if we set it equal 0, then 4x minus 1 equals 0. We solve for it. 4x equal 1, and x divide both sides, x equal 1 over 4, right? We all know how to solve the equation. So that's the case, and that's why we have a 4 times x minus 1 as the vertical asymptote, so that we have satisfied this condition. Okay, what else we know? Now we know that the degree on top have to be equal to the degree at the bottom. And we also know that we have a whole as 5. It means on the top we have something like x minus 5. And down here we also have x minus 5. So that we can cancel and we make a whole right here, right? And x equal 5. Now, what else do we need to put in on the top? X-intercept equals 0. That's interesting. Now, x-intercept equals 0. If we set this equals 0, if we set this function, right? This function is y function equals 0, we solve. And all we have to do is solve for the numerator, right? Because that's how the numerator make this equation equal 0. So if we solve like this, turn out we do have an x-intercept, and our x-intercept equal 5 if we don't do anything about this. Unfortunately, it will contradict with this statement, right? The statement here say we don't have an x-intercept. We cannot have an x-intercept equal 0. We have to change it. So now we have to change it. So how do we change? Let me toss in an extra x here and see what happens. Obviously, when you have an x here, you set equals 0, then yes, we do have an x-intercept as x equals 0, right? So we have to toss in x. Also, it helps us to establish our degree on the top equal the degree at the bottom. But do we need that? We have vertical asymptote. It doesn't say anything about horizontal asymptote. Let me check the question again. See, did I miss anything? We have vertical asymptote that's x equal 1 over 4, x-intercept equals 0, discontinuity. No, we didn't miss anything. So that's the information. So we don't care about horizontal asymptote. Actually, we don't care. All what we care is satisfy on this condition, right? So now let's write this equation. Let's lay this as a long form and let's simplify it so that we can put in the calculator and draft it, right? To make it easy. So if we want to simplify this, we'll cancel this with this one. And therefore on the top, this equation will become h of x equal x divided by 4x minus 1. So that is the simple form, simplest form of the equation. We can put in the calculator and analyze it, okay? So let's see. So I am going to put in the simplest form. So on the top will be x divide, open the bracket, 4x minus 1. Now I'm going to sketch it. It's something not clear, right? It have it, but it's not so clear. So I have to change the zoom or change the window. Let's say if I zoom on and I'm going to put 4 for decimal and change it and see how it look like. So now you'll be able to see the shape of the function, right? It's something like that. Okay, so let's check. We have the vertical asymptote at x equal 1 over 4. We cannot check that, but you can see it right here, right? There is an asymptote going on here, and it's very close, like 0.25 something. So it seems to be correct. We also have the x-intercept equals 0, right? So let's key in x equals 0 and enter. You see the y value at the bottom here, say x0, y0. So yes, we have x-intercept, and it highlight it, right, flashing on the on that whole on that point. You can see that. Okay, what else we need to know? Okay, we also want to check the value of the home, right? We have a home at x equals 5. Now, if I key in exactly number 5, we might not see the value of y. But let's go back and let me clear this first. Let me go back and let's say, what is the value of y? If I use 5 divided by 19, what do I get? I get 0.26, right? So we'll write this down. This equals 0.26, right? This fraction. Same like 0.26. Now, I'm going to be careful. I'm going to key in x equals 4, okay? I'm key in x equals 4 on the right. So trace x equals 4. I get close 0.26666. But let's say if I key in x equals 4.5, it's same thing, right? A little bit change, but very much the same. Let's say if I do 4.7, still 0.26, right? You can see here, x equals here, y equals there, right? So now let's key in x equals 5 and see what happened. Error. See that? It means that at x equals 5, we do have a hole. It error. The function does not exist. Okay. So let's go back to the graph. Now we know that if I key in 4.5 very close, I still trace and 4.7, right? It still works. Yeah, we have 0.26. When it close to 5, right? That's the value of the y. So it very much, everything we do so far, we did so far, were correct. And that is how you write a rational function and using the graphing calculator to check our work to see whether or not our rational function are correct or not. Okay, so I hope you enjoyed this video so far, and I might teach another video similar like this question because this topic is complex, right? I found it challenging when I was learning this topic when I was in high school, to be honest. First of all, because sometimes in the classroom, teacher went fast, and also we did not see the whole picture. So when I am putting on my course online, I try to show you on the information and I try to put them in the logical sequence, and that's important, right? At the higher level of math, the logical sequence of explanation follow the step from simple to complex to make students understand. That is very important. That is the most important when you are teaching math at the at this level, like calculus or recalculus, whatever, right? Anyway, even though when you teaching the elementary, I guess, like each topic require a different way of teaching, and require you have to be patient. So anyway, I hope that you enjoy my video, and Sometimes I go too slow or too fast. Please give me a comment to let me know so I can improve my teaching as well. And thanks for watching. Bye for now.